Materials, bio-based products, and energy derived from renewable biological material can reduce emissions in a huge number of ways. On the banks of the River Danube in Hungary, Pannonia Bio operates the largest single-site biorefinery in Europe, manufacturing a host of products with environmental benefits to multiple industries.
From humble beginnings more than 10 years ago, this grain biorefinery in Tona County, Hungary, has grown immeasurably. Here, corn is transformed into a diverse range of products, including food, feed, energy and fuel. It supports local farmers and livelihoods and develops sustainable solutions to global challenges.
Everything that comes in a truck is made into a product and sold. We take a product like corn that has 12% protein and the rest is starch basically, and we make that into a 37 or 38% protein animal feed, which is very high end. The starch we make into ethanol, which goes straight into your car, and it's blended in most European countries at 10%. We make ENA, extra neutral alcohol, which gets sold to companies for vodkas and gins. And it's 80 acres of different factories.
The safety and smooth running of the site is managed from this central control room.
Within 12 years we've grown complexity significantly.
And it's here I met Pannonia Bio's CEO.
Even at the beginning of establishing Pannonia, the circular economy principles were in our mind. That's why our research and development team is targeted with trying to decompose corn kernel on different elements that are either used as a value-added product as corn protein concentrate or as a waste that can be reprocessed.
The company is also actively looking to increase its own energy efficiency. Electrification of the biorefinery by means of mechanical vapor recompression has helped to decarbonize the distillery by significantly reducing natural gas consumption by 1/3.
The alcohol production is a very energy-intensive process. Most of the energy that we put in the distillation columns is lost in the cooling towers. Further down, we have to put more energy in the dehydration system. What we have done here is trying to integrate these two sections with MVR technologies. By the implementation of this project, we have reduced our carbon footprint.
And biogas production is further reducing the plant's dependence on fossil fuels, as well as providing biomethane for the national gas grid.
As you can hear, it's incredibly noisy here. That's because in here, the fibre is being separated from the rest of the corn. Now in future, that fibre could be used as a high-quality prebiotic food additive, but for now it's being used as feedstock for the biogas plant here. It's another example of the way in which this site is managing its energy transition.
Biogas is either used internally, substituting our natural gas demand, or we purify it, removing CO2 and water, and pure methane, which is produced from a sustainable resource from corn, is put back into the gas grid. At the same time, output of biogas production is an organic fertilizer coming out from the anaerobic digesters that we dry and pelletized, and it's going to be used by farmers in organic farms.
The future of the food industry will also rely increasingly on plant-based raw materials, and barley as well as corn concentrates and isolates are in huge demand.
And our barley protein and our corn protein for humans, we're making that at a low cost on a huge scale. And that'll be protein that's been made not like pea protein or soya protein, which is unsustainable or people don't want to buy it. It'll be a protein that's made without chemicals put into it, or dyes put into it, or colours taken out of it. It'll be natural. So we're very proud of that.
It's another shining example of biorefinery sophistication. This is a plant with innovation, sustainability, quality and affordability at its core. A nursery for new bio-based technologies that promise to benefit both human and animal health.